Hi everyone, and welcome to Honors Math Analysis, Chapter 12.1. My name is Marcus Chua, and today I'm going to be talking about sequences. First off, a quick explanation about what sequences are. By definition, a sequence is a function whose domain is the unending set of positive integers. Terms can be defined as the numbers in a sequence. Shown below are two graphs. The graph on the left is a function where the domain is all numbers that are greater than 0. The graph on the right has a similar shape, but it can be identified as a sequence because its domain is the set of positive integers. When we write sequences, we have a few options for notation. First is brace notation. When a formula for the nth term, sometimes called the general term, of a sequence is known, we can use brace notation by representing the entire sequence with braces around it. Next, we can also use recursive notation. Recursive notation is where we assign a value to the first or the first few terms, and we can specify the nth term by using a formula or equation that involves one or more of the terms preceding it. Finally, we can use summation notation. Summation notation is usually used to express the sum of terms in a sequence. We use the Greek letter sigma as an indication to sum up the terms in a sequence. Here are a few properties of sequences using summation notation. These properties are very useful for adding the terms of a sequence algebraically. Additionally, we have some formulas for summation notation. Again, these formulas are very useful for adding up terms of a sequence algebraically. Let's look at a few examples. Example 1 asks us to write down the first 6 terms of this sequence and to graph it. So we can see that we are given a sequence in brace notation. And so in order to solve this, we would input the first 6 positive integers and put them into the sequence. So when we do this, we get these following terms for c sub 1 through c sub 6, and then we would graph these terms with 1 through 6 on the x-axis and the resulting terms on the y-axis. Next, for example 2, we are asked to write down the first 5 terms of the following recursively defined sequence. Here we can see that we are given u sub 1, u sub 2, and the recursive sequence. So again, we are able to solve this by inputting u sub 1 and u sub 2 into the recursive sequence, and using the recursive sequence 3 more times in order to find u sub 3, u sub 4, and u sub 5. And here, by doing this, we get the resulting terms. Finally, with example 3, we are asked to find the sum of the sequence in summation notation. So, in order to do this, we are able to use our properties of sequences and our formulas for these sums of sequences. So when we do this, we can, for the first step, we can use property number 2 in order to separate the summation notation. And moving forward, we can use formulas number 8 and formula number 5 in order to split up the summation notation into an algebraic formula. From there, we simplify, and we are able to reach a final answer of 3035. Thank you very much for listening.